Assalamualaikum warahmatullahi wabarakatuh. Well, in this video, I'm going to talk about an example of classic permutation problems. So we are going to look at some classic permutation problems. And to be specific, we are going to look at the problems of selecting R objects out of n objects and then arrange them in some sort of order. Okay, so this is a classic example that we have here. We have 4 letters A, B, C and D, and the question is asking you for the number of permutations if you take only 2 out of 4 letters. And I'm sure you do remember some of the permutation formula that you have learned in school, but right now I'm just going to illustrate to you how we can use the basic counting principle which you have seen in theorem 1.1. So I'm going to use that kind of approach where you try and visualize the process as one big operation that can be further segmentized into smaller steps. Okay, so that's my thinking process, and that's how we're going to start off our discussion today. So here we have a big problem, which is choosing two hold on. Okay, we're going to have the problem of arranging 2 out of 4 letters. Okay, so this is the problem that we currently have, and we can think about this process by starting with the small step of choose the first letter. So in the first step here, we're going to choose the first letter. Okay, and on the second step is we are going to choose the second letter. Okay, so here we have basically 2 spaces that we're going to consider putting whatever alphabets, either A, B, C and D. Okay, so if we go and look at this, we know that for the first stage here, the first step, if you want to choose the first letter, you have 4 different options. So n1 here is going to be equal to 4. Okay, it makes sense, right? Because you have 4 letters, so you have that 4 choices. Now once you have filled out this space and you want to choose the second letter, the number of choices that you have on this second step or second stage here is going to be reduced to 3 possible options, because this one has already been filled up with 1 alphabet. So here we only have 3 alphabets to choose from. Okay, therefore the number of permutations, okay, the number of ways you can arrange 2 letters out of 4 letters is going to be, so here I'm going to write down the number of permutations is going to be obtained by multiplying 4 and 3. So it's going to be equal to 4 times 3, and this is going to be equal to 12. So there are going to be 12 different ways of choosing 2 out of 4 letters and arrange them. Okay, now let's see if the question further asks you to list all the arrangements. Okay, so if they ask you to list all the arrangements, for some students it can be quite daunting process because they might have missed some of the possible arrangement. But bear in mind that altogether it should be 12 different arrangements. And if you really can't be systematic about it, like I said earlier, hang on, I'm just going to erase this part. Okay, if you can't be if you think that you are not systematic enough and you feel like you might have missed some of the possible arrangement, then you can always try visualize this problem using a tree diagram. Okay, so tree diagram, like I said earlier, is a powerful tool that enable you to see all the possible options. Yes. Okay, so imagine that in the first stage of choosing the first letter, so this is the first stage of choosing the first letter. So choose the first letter. You have four options. So you have A, B, C, and D. Okay. Next, once you have arrived at this junction here, now we have arrived at the second stage of choosing the second letter. So we're going to choose the second letter, and if you have already chosen A in the first stage here, so you can only choose B, C, and D. So if you have already chosen B, that means you only have A, C, and D as your possible options. If you have already chosen C, that means you only have A, B, and D. And finally, if you have chosen D in the first stage, that means you only have A, B, and C. So clearly, you will be able to list all possible arrangements without the fear of missing any combination. Okay, so here we have A, B as the first combination, and here we have A and C, and then we have A and D. Next we have B and A, B and C, B and D. This one we have C and A, C and B, C and D, and the last leg that we have here is D and A, D and B, and D and C. So altogether is 12 different ways. Okay, so again I have solved this permutation problem using the idea of counting rule, which I have illustrated in the previous video, in my earliest video. And if you can't recall what is it all about, you can go to this lecture note and refer to theorem 1.1. Okay, now let's move on to this example 1.6 here, where you have like 10 different colored balls, and how many different ways you can draw one ball, of course without replacement, 2 balls, 3 balls, 4 balls, and what if you decide to draw odd balls. Okay, and what I'm trying to demonstrate to you by this exercise is actually that the above problem here, I will demonstrate to you using the idea of basic counting rule, but then you will see that this process will lead you to obtain the solution or the formula which is similar to this one here. So this is the formula, or the permutation formula, which you have actually already seen in schools. Okay, so this is you have n objects, and you choose R out of this n object. So this is the permutation formula. Okay, so basically this exercise is going to demonstrate to you guys how the way of thinking from the idea of basic counting rule will give some sort of similar formula to what you have already learned, which is NPR. Okay, all right, let's try and do this now. Okay, so again, suppose that we have 10 different balls. Okay, I'm going to illustrate question A here. So you will have uh, only one step because you only draw one ball. Okay, so here we have step 1, which is choose one ball. And of course, in this step 1, your number of ways of choosing one ball is going to be equal to 10. Okay, so you can imagine this is the things that you have to, this is the space of choosing one ball, and you have 10 different options. Okay, 10 different options. All right, now if we move on to the next question, you're going to draw two balls. Okay, so here we have step 1 of choosing the first ball. So here obviously n1 is going to be equal to 10. Okay, because this is the first stage and you're going to choose the first ball. You have 10 balls altogether, so you have 10 options. Okay, now in the second stage, step 2, you're going to choose the second ball, and here the number of ways is going to be reduced to 9. Okay, so imagine that this is the space for the first ball. You have 10 options. So if the space is already been filled up, then the next space, which is for the second ball here, the number of options that you have is going to be reduced to 9. Okay, to 9. So the number of ways that you have is just going to, you're just going to multiply 10 with 9, and this is going to be 90 different ways of choosing two balls from 10 different colored balls. Yeah, and for this one you just have 10 ways of choosing one ball. Okay, all right, let's look at the next question, which is question C here. So for question C, we are going to follow the same idea. So the first step, so this is step 1, we're going to choose the first ball. So you have 10 options altogether. Okay, and then in the second step, you're going to choose the second ball. So you are reduced to 9 options because this space has already been filled up. And then the third step is to choose the third ball. The third ball here. So this space is already filled up. This is already filled up. So the number of options that you have is going to be equal to 8. So far so good. Are you following this discussion? So we have 8 options because you have already chosen 2 balls. Okay, so now the options that you have on the third stage is just going to be reduced to 8. And therefore, the number of ways, according to the basic counting rule, if you multiply all these numbers together, then you will get the number of ways you can choose 3 balls from 10 different colored balls. Okay, so that will be equal to 10 times 9 times 8 is going to be equal to 720 ways. All right, now I just need this space to continue writing. So now let's move on to the next question, which is choosing 4 balls out of 10. Yeah, so we're going to follow the same argument, the same discussion that I've already demonstrated to you guys. So here we have choosing the problem of choosing 4 balls. So here we have the first step is to choose the first ball. So we have 10 options altogether. Now the second step here is to choose the second ball. Since this is already been filled up, you have 9 options that are left for you to choose. And then this is the third step, to choose the third ball. So you have 8 options. and then this is the fourth step, which is going to be 7 options that are left for you to choose from. And again, if we follow the idea of basic counting rule, if you multiply all these numbers, all these numbers, then you will arrive at the number of ways you can choose 4 balls out of 10 balls. So here we're going to get 10 times 9 times 8 times 7, which is going to be about 4,040 ways. Okay, so here basically, if you can think about the number of total objects, so number of total objects is, I'm going to call it n, and n here in this case is equal to 10. Okay, and the number of objects that you selected, number of objects selected is going to be called r, and in this case r is equal to 4. Okay, so similar to what we have already done here. So here is n is equal to 10 and r is equal to 3. This one is n is equal to 10, r is equal to 2. N is equal to 10 and r is equal to 1. You select only one ball. Yeah, okay. Now we are going to move on and see what happens if you select r balls from, let's say, 10 different balls. Okay, so if you select r balls, so we are going to select r balls out of 10 objects or 10 balls. Okay, therefore if we follow this pattern here, we can have this is the first step. You have 10 options. Okay, this is the second step, which is reduced to 9 options that you have because this space is already been filled up. This could be the third step, which is reduced to 8. And imagine you go through the process, and this is going to be rth step. Yes, okay. How do I know this is rth step? Well, we follow the pattern here. If you choose r equals to 4, here is the end of it, which is at the 4th step. So if I choose r balls, so the last step is going to be rth step. And how many options do I have here? So the options that I have here is going to be 10 minus r plus 1. Okay, because here if you have r equals to 4, then the result here is 7. So 7 means 10 minus 4 plus 1. So I'm just following the pattern really. Okay, I hope you can see that. And similar to this one, if r is equal to 3, the number here is 8. So 8 can be obtained by having 10 minus 3 plus 1. Yes, so we got 8. Therefore, for this one, we get 10 minus r plus 1. Okay, I hope that you guys are following this discussion here so far. Okay, so now we're just going to manipulate, okay, as this situation. Okay, I'm just going to show you this one right now. So this guy over here, okay, I'm just going to manipulate the situation. So here we have 10 times 9 times 8 times 7. So this is what we have over here. Yes, and let's say that I introduced a term. Okay, I'm going to introduce a term that is not going to change whatever that you have seen before. So I'm going to introduce a term that is 6 times 5, 4, 3, 2, 1. Okay, 6 times 5 times 4 times 3 times 2 times 1. So I hope you can see that when I introduce this term, I haven't changed the actual expression that I have here, because this is something like introducing 10 times 9 times 8 times 7 multiply with 1, because here we have both similar terms that can be cancelled out and this can become 1. So multiplying 1 with this term here doesn't change what I have originally given in this part. Yes, okay, so I'm just introducing something that doesn't change the original expression, but you will see later on why I introduce this term here. Okay, so I introduce that. Now I hope that you can see, if the process here is, then you can write down this thing here, the whole thing here, as 10 times 9, 8, 7, and then multiply with this term here, so 6, 5, 4, 3, 2, 1. This one is over 6, 5, 4, 3, 2, and 1. Okay, and I hope that you can see this part here is just 10 factorial, and this part here is 6 factorial. Okay, and I can further write down, this becomes 10 factorial over 10 minus 4 factorial. 10 minus 4 factorial. Okay, and actually this is something that you have seen, or you have, I believe that a lot of you have been using this formula, which is the general formula here is actually n factorial n minus r factorial. So that's the process. Okay, you can see that I started off our discussion with the idea of basic counting rule, but then you can arrive to this conclusion of using this permutation formula. Okay, so if you look at this part here, the result that we're going to have is 10 times 9 times 8 times blah 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 times 10 minus r plus 1. Okay, times r minus 10 minus r plus 1. Now what I'm going to do is I'm going to introduce a term, okay, a term where it's going to be multiplied with 10 minus r, okay, 10 minus r, and then after that it will be 10 minus r minus 1. So the term is keep on reducing, right? And then blah 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 2 and 1. Okay, so this is what the process looks like, and I'm going to have the same term at the bottom here. Okay, therefore, by having the same term at the top and the bottom, it's the same thing as multiplying this guy here with 1, so it doesn't change the original expression. Now the whole thing here, we can write this whole thing in terms of 10 times 9 times 8, and then we have 10 minus r plus 1, and we're going to multiply that with this expression here. So we have 10 minus r, and then we have 10 minus r minus 1, blah blah blah, until 2 until 1. Okay, so at the bottom here we have 10 minus r times 10 minus r minus 1. My pen here is a bit slow and it's not sensitive to my writing here, times 2 times 1. And I hope that you can see from this part here, this is actually the same idea as having 10 factorial. So this is actually 10 factorial. And if you start off with 10 minus r and the number here get reduced, therefore this part here is actually 10 minus r factorial. And again, it goes back to the general formula. If 10 is the number of objects that you have, so n here is 10. So basically what you are seeing here is the same thing as applying this formula here, the general formula, which is n factorial at the top part, and at the bottom is n minus r. Okay, all right. So we go back to this here, where I have looked at some classic permutation problems. Okay, I've looked at these classic permutation problems, and I have started my discussion on how to solve this problem using basic counting rule. But then you can see that the process is actually similar if you just directly apply this formula. So this is known as the permutation formula, which you have learned in school, and you will arrive at the same answer really. Okay, right. Perhaps to conclude this whole process here, I'm going to leave you with this example. So this is an example of classic permutation problem where you're going to have 4 positions to be filled up: president, vice president, treasurer, and secretary, and you have 24 members. So this is n, number of members that you can choose from. So here we have 4 names, and you can find the number of different ways that this can be done. Is going to be 255024. I'm sorry for the disturbance